Welcome to the Explainer. Okay, I want you to picture something with me. Imagine you're standing right in the middle of a chaotic, high-stakes trading floor. The clock is relentlessly ticking down, the pressure is completely immense, and every single split-second decision you make dictates your ultimate payout. Well, guess what? That exact environment is exactly what you face when you sit down for the Cambridge Mathematics examinations, specifically papers 0580 and 0606. You aren't just solving math problems in that room. You're an investor, and you need to invest your highly limited time exactly where the mark yield is the absolute highest. So today, we're decoding the ultimate high-stakes challenge, maximizing your marks in the Cambridge IGCSE Additional Mathematics syllabus. We are going to treat this explainer like a fast-paced strategy session. We're stripping away all the fluff and focusing exclusively on those split-second decisions that separate the top-tier candidates from, well, the rest of the pack. So get ready, because the trading floor is officially open. I really want you to notice the sheer certainty of this statement. This isn't just a guess. It's a direct mandate from a senior examiner. Mastering the integration of functions in the form of ax plus b all to the power of n for any rational n, including n equals -1, is absolutely non-negotiable. Seriously, let that sink in for a second. This specific calculus topic appears in every single examination series. No exceptions. If you walk into that exam hall without a bulletproof strategy for integrating these functions, you are literally leaving guaranteed marks on the table. It's like walking onto our trading floor and completely ignoring the most reliable, high-yielding stock on the board. The examiners know this is a stumbling block, and they test it relentlessly to separate the superficial memorizers from the students who truly grasp the analytical framework.
So here's our masterclass blueprint for today. We're systematically decoding the examiner's rubric to guarantee you secure those top marks. We're going to hit the integration challenge, dive into the theoretical foundations, break down the technical methodology, uncover some critical examiner insights, and finish up with the final strategy.
Right, let's jump straight into Section 1, the integration challenge.
To truly master this calculus hurdle, we really need to look at two specific behavioral traps that catch students out every time. Let's talk about Alex and Sam. I want you to think about which of these two profiles you relate to the most when that exam pressure hits. So Alex is a total workhorse. When Alex sees an integral like 3x plus 2 all to the power of 4, panic sets in. Alex overloads the page with raw mathematical facts, deciding to completely expand the bracket using the binomial theorem. I mean, think about that. Wasting 10 precious minutes, filling a whole page, and completely ignoring the analytical shortcut of the reverse chain rule. There's no structural analysis there, just pure brute force. And the result? Red pen marks everywhere for an incredibly inefficient methodology. Now, on the flip side, we have Sam. Sam is fast, but Sam rushes. Sam completely misses the specific command word requirements of the question. Sam integrates the power perfectly fine, but completely forgets to divide by the derivative of the inside function, that all-important a coefficient. Oh, and Sam also forgets the constant of integration, the plus c, because Sam isn't pausing to look at the context of an indefinite integral. Both of these approaches lead to lost points because they rely on either raw, panicked memorization or just plain rushing.
That brings us right to Section 2, theoretical foundations.
We desperately need a new architecture here. The conceptual framework for integrating ax plus b to the power of n isn't just about regurgitating a formula. It draws heavily on established principles of systematic analysis and evidence-based reasoning. We need to shift our entire focus to the exact assessment objectives the Cambridge rubric is demanding. This is your golden ticket right here, the method mark strategy. This is an exam grading framework where marks are awarded for systematic processing, clear working, and structural thinking. Academic benchmarks here require logical, structured reasoning. The assessment framework prioritizes analytical depth over superficial breadth. The examiners honestly don't just care what your final answer is, they care intensely about how you mathematically justified getting there. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
So, I really have to ask you this. Why do students find evaluating their mathematical evidence and drawing conclusions so incredibly hard, especially when you're dealing with boundary conditions or contextual calculus problems like kinematics? I'm going to set a 30-second mental timer for you right now. I want you to truly think about how you structure your written answers when asked to justify an integration step. The very best students use the PEL framework: point, evidence, explanation, link. Yes, even in mathematics. They make a point about the integral, they provide evidence by stating the correct mathematical rule, they explain the algebraic steps clearly, and they link it back to the original context of the question. Are you just scribbling numbers on a page, or are you actually evaluating the evidence? Listen to what the principal examiner reports explicitly state. Candidates who reference cross-topic connections achieve significantly higher marks, period. The theoretical architecture of integration rests on precise definitions and its integration with other syllabus areas. Top-tier students don't just solve an integral in total isolation. They recognize when an integral of an ax plus b to the power of -1, which, remember, requires the natural log function, links directly to calculating the area under a hyperbolic curve, or how integrating an acceleration function intrinsically links to velocity in kinematics. Showing this causal relationship proves you have analytical depth rather than just superficial breadth.
Let's transition over to Section 3, Technical Methodology.
This is the transformation phase. This is where we take the red marks that Alex and Sam got and we turn them into brilliant, point-scoring green check marks. But to do this, we must follow a strictly standardized procedural framework. You literally cannot just wing it on exam day. Step 1, deconstruct the question. Ask yourself, are you evaluating a definite or an indefinite integral? Step 2, extract relevant data. Exactly what are your a, b, and n values? Pin them down. Step 3, select the analytical framework. If n equals -1, you immediately select the logarithmic framework. If n is literally any other rational number, you select the reverse chain rule power framework. Step 4, execute with clear notation. I'm talking about proper integral signs and dx notation. Do not drop them. Step 5, present with correct terminology. Let's actually do a live 60-second rewrite in our heads for our friends Alex and Sam. Instead of Alex desperately expanding that massive bracket, we guide Alex straight to step 3, selecting the right framework. We just increase the power by 1, divide by the new power, and multiply the denominator by the derivative of the inside bracket. Instantly, a 10-minute brute force disaster becomes an elegant 30-second solution. And for Sam, who always rushes, we enforce step 4 and 5. We make absolutely sure Sam writes down the plus C, verifying that the presentation follows strict mathematical conventions. Red turns to green just by respecting this 5-step sequence.
I need this syllabus code to burn into your memory. 0606. This is the additional mathematics arena. The demands here are rigorous. Systematic processing and clear annotation aren't just nice-to-haves, they are the absolute baseline. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's dive deep into Section 4, Examiner Insights.
We are now launching the interactive workshop phase of our explainer. We need to look directly at the data interpretation skills required for extracting evidence from texts and complex mathematical tables, pulling this straight from the examiner's desks. I want you to imagine a complex table outlining the parameters, coefficients, and rational powers for evaluating these functions. We're initiating Challenge 1, the data scan. Picture a 60-second visual countdown timer on your screen right now. Scan the data. Extract the core trend. What actually happens when the coefficient a becomes a fraction? What happens when the rational power n is a negative fraction? Your data interpretation skills here are absolutely critical. You must be able to interpret the relationships between these parameters and draw evidence-based conclusions on how they stretch or compress the resulting integrated function. If you miss a tiny negative sign on a fractional power during your scan, your entire calculation completely collapses.
Now, let's move into Challenge 2. We're looking at the top 3 warnings straight from the principal examiner reports. Number 1, using the wrong approach for the wrong context. Number 2, forgetting to check format and presentation. Think missing brackets or dropped dx terms. And number 3, answers that are not specific to the context given. Think about our memory hack here. Let's create an acronym for these. Call it AFC, Approach, Format, Context. Before you finalize any integral, run it through the AFC check. Are you making that classic trap of integrating ax plus b to the power of -1 using the power rule instead of a logarithm? Well, that's the wrong approach. Are you presenting it messily? That's bad format. Are you forgetting it's a kinematics question and leaving velocity as an abstract equation without solving for c using your initial conditions? That, my friends, is ignoring context.
Let's see the exact examiner alert we just discussed, but in action. Think about a generic, non-specific integration answer versus the top-scoring one. A generic answer is just numbers randomly scattered on a page with zero logical flow. The classic mistake is providing answers not specific to the question context. But a top-scoring candidate? This student is proactively justifying their decisions with evidence and context. They demonstrate evaluative thinking by laying out their assumptions clearly. They write things like, since t equals 0, v equals 5, we can determine c. They evaluate the evidence quality, they state their methodological choices perfectly, and they secure every single available method mark. You must always link every mathematical point back to the given scenario.
So the most crucial point is applying all of this practically. This is challenge 3, speed writing. I want you to mentally, or physically if you have a pen handy, start a 30-second timer. Your task is to write one perfect Peel paragraph demonstrating critical analysis of an integration problem involving a rational power. You make your point about the exact rule you chose, you provide evidence from the given equation, you explain how the rational power affects your fraction when you divide by it, and you link it back to the limitation of the domain. You must question your assumptions. What if x makes the bracket 0? That's an alternative interpretation that fundamentally affects your conclusion. Speed, accuracy, and structure. That's the name of the game.
We are now transitioning into our final act, Section 5, the final strategy. We're going to consolidate all of these theoretical frameworks, examiner insights, and technical methodologies into an actionable, completely foolproof exam strategy cheat sheet. This is your ultimate playbook for the trading floor. Here are the 3 absolute rules for exam mastery. Step 1. Command word decoding. When the exam says evaluate, it means something entirely different than find or show that. If you don't decode the command word, you're just answering a question they didn't even ask. Step 2. Peel framework application. Structure your mathematical reasoning. Make your points. Show your evidence. Explain your steps. Link to the context. Step 3. Time management matrix. You must recognize instantly if a question is a quick 2-mark procedural application or a massive 7-mark cross-topic comparative analysis and invest your time accordingly.
And here is a critical memory hack to take with you. The comparative analysis protocol. Sometimes you're going to need to compare 2 different mathematical models derived from integration. You must identify similarities and differences. Use comparative connectives, words like whereas or conversely, when comparing rates of change. Support each comparison with actual numeric evidence derived directly from your integrals. And finally, draw concrete conclusions about their relative importance. This protocol ensures you systematically evaluate your integration steps before submitting your final answer. That number right there is massive. 2. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. That is literally the difference between a B and an A star. But it only happens if you apply the systematic processing we've talked about and stop relying on panicked brute force memorization like Alex or careless rushing like Sim.
Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. The trading floor is ruthless, but with the right analytical framework, those maximum marks are entirely within your grasp. See you next time.